Hi, welcome to the video. Have you ever tried opening half a GB of file on your machine? Irrespective of how high-end the specs of that machines are, chances are that you might have faced some or the other problem. One of the problems that you might have faced is it would have taken some time for you to open that file. 5 minutes, 10 minutes, maybe more. These are the kind of problems that we are talking about over here. Now, half a GB of size is a minuscule amount of the actual size of the file that you're going to come across in the big data files. The minimum size that a big data file starts with is at least 1 terabyte. Now imagine if you try to open that on your machine, how much time it is going to take or how many challenges you are going to face in terms of opening it. Leave apart the fact that you have to do some analysis on it, some searches on it, or you're trying to just plain access it. That's where technology like Hadoop comes into picture. Hadoop provides an underlying distributed file system, and on top of that, an analytics algorithm which helps you do analytics on top of these saved files. So what we are going to understand now is what is big data. We are going to list out the limitations of the existing solutions. So we already have some existing solutions in terms of RDBMS and data warehousing. So we are going to understand the limitations of that. We are going to move on to define Hadoop, what are the basic constituents of Hadoop and its components, its ecosystem. Then we are also going to say that the challenges or the limitations that we face in the existing solution, how Hadoop helps you to overcome them. Let's look at the brief history, how this all started about. In around 2002, Google was also facing the same problem. It was having challenges in terms of saving these huge files which it was accumulating by way of saving these web addresses of all the web addresses that it provides to save on its servers. Now Google went to the fundamentals. It tried to use the concepts of distributed file system, and it tried to lay an architecture of a distributed file system, and it tried to save that data on the distributed file system. The problem that it faced with that is, first of all, Google has to manually do it. Now it needed a framework, it needed a mechanism such that these files are saved automatically. That is where Google wrote a white paper called as Google Distributed File System. Now, at about the same time, a person by the name Duck Cutting, who basically coming from a search framework development background, was also working on the same. Duck Cutting, by the way, is the inventor of the Lucene search engine, the all popular Lucene search engine, which is very popularly used, very famously used in the Java world. Duck Cutting saw that white paper and he started making an implementation of that. That started happening somewhere around 2002, 2003. Yahoo was observing this. What Yahoo did was that it hired Duck Cutting and it told him that you can go ahead and do a full-fledged implementation of it. Duck Cutting took 2 years to do a complete implementation of it, and that's when Yahoo implemented Hadoop as a framework in its full-fledged production environment. Later on, Yahoo donated the framework to Apache and it became a full-fledged project on Apache. Now, back to Google. Google has solved the problem of saving the data. Now it wanted to do something more on top of it. It wanted to do analytics on top of it. That's when Google wrote another white paper called as Google MapReduce algorithm. Again, Duck Cutting and Yahoo had a look at that paper and they implemented that into their own solution. Again, it went back to the production environment, and then Yahoo donated it to Apache as a full-fledged project. That's how Hadoop came into the picture, right? Now, as I said, big data is about at least a terabyte or a zettabyte of file. Hadoop is a framework which helps you, first of all, save that file, and secondly, do analytics on top of it. We saw the challenges in terms of file when it starts from a 1 terabyte file of size. You have problems in terms of saving it and accessing it. Hadoop as a framework helps you to, first of all, save this file by way of its distributed file system, and then once the file is saved, it helps you to do analytics on top of it. And that analytics is done using the MapReduce algorithm of Google MapReduce algorithm implementation. Now, let's see what is the kind of data which is saved in this big data files. Let's again look at a little back, somewhere around a decade back. From around 75 to 80s, we all know that we've been working on transactional systems where the name of the game was relational databases. We had fixed schemas with fixed tables, fixed rows, and at the relational database level, and people knew that what is the kind of data stored that they have to align to, and they have to build their applications on top of it. It went on till for a decade, till around early 2002. That is when applications like Facebook, Twitter, and LinkedIn started coming into picture. Now, the kind of data that these applications were generating were more and more unstructured. Let me tell you what unstructured means. While in structured data, at the start of it, you know what the database table is going to look like, how the rows are going to look like, how you're going to save the data. The unstructured data would be comprising of various different formats, like audio files, like video files. I mean, take for example, the kind of data that you put on a social networking website like Facebook. You would you would post your videos over there, you would post your audios over there, you would post your images over there. Now that in turn at the application level becomes an unstructured data. So the proliferation of this data started happening from somewhere around mid 2004, 2005, right? And that is when the data started becoming more and more unstructured. Now the problem that the traditional data stores like RDMMS were facing was how to store this data. While on one hand, this data did not have the structure, on the other hand, the size of this data was becoming humongous. It was complex, it was unstructured, it was huge, and it was growing. Now, at the same time, while Yahoo was working on the Hadoop implementation and Google was developing the white papers, IBM also jumped into the fray. It created its own definition of big data. And namely, it kind of defined the concept in 4 different parameters. Those parameters are volume, variety, velocity, and veracity. Now, volume, as you might have guessed by now, it's about the humongousness of or the size of the data. So IBM said that the size of the data is increasing from the last decade or so, and the next decade or so, it is going to become at least double, if not triple of what size we have. Then there is so much variety that is coming into the picture. You've got audios, you've got videos, you've got posts, you've got images, you name it. You don't know the structure and you don't know what type of data that is going to come into the system. And then the velocity, the speed at which the data is getting generated is huge. And also, along with the speed, the need to do analytics, the need to do speedy analytics on top of the data that is getting generated, it is also increasing. And then the veracity. How would you know that the data that is getting generated is a genuine one? If you have a huge data and you are doing analytics on top of it, what is the guarantee that the results that you are getting is genuine, it's right, and it is going to be of help to you? So these are the 4 parameters which IBM took to define big data as a concept. So now let's look at the limitations of the existing solutions. Now, what are these existing solutions? There is data warehousing. Now, we all know that data warehousing builds on top of RDBMS data store. Now, the limitations that this poses is, first of all, the RDBMS has got a fixed schema. The table, the schema, the rows, the columns, everything is described right up front before the database moves into production. Another obvious problem is that you have a cost associated with it. All the leading providers like Oracle, like MySQL, like MS SQL have got a commercial aspect to it. Now the third problem is that if you have a file like 1 zettabyte of size, first of all, you'll have problems in saving it on these systems, because these systems are not meant to be saving that huge a file. Now, if at all you're able to save it, another problem that you're going to face is when you're trying to access it. If you are trying to access it through some web solution or some web page, it is going to take a long time for you to access it. If you're trying to do analytics on top of it, as I said, if you're using a solution like data warehousing implementation, you cannot take the entire population of data to do your analysis. You'll just have to rely on only a small portion or a small subset of the data to do your analytics. Because if you're using the entire population, it is going to take a lot of time for you to do the analysis. Sometimes days, weeks, or maybe months. Now let's look at what is Hadoop. Simply put, Hadoop is a combination of a distributed file system and an analytics algorithm. Now the distributed file system helps you to save this big data file, and the MapReduce algorithm helps you to do analytics on top of it. All that in a very speedy time in a very quick time, on a set of commodity machines in a cluster, right? Now by commodity machine, what I mean is machines like what people like me and you use it, and with a very simple programming model, and that programming model is MapReduce algorithm. Now the beauty of that is it's all open source, so there is no cost aspect associated with it, right? So it comes free of cost. Now, having understood basically what Hadoop is all about, let's see what the Hadoop ecosystem is. Hadoop ecosystem is not only a distributed file system or the MapReduce algorithm, it's also a couple of other components which have been made to provide certain other conveniences. One of these ecosystem component is Hive, which basically is something which is similar to what data warehousing solution provides. The difference over here is data warehousing uses only a portion of the data. Hive uses the entire population of the data. Then you've got Pig Latin and Pig, which basically again an abstraction on top of your underlying MapReduce and HDFS implementation. Then you've got Mahout. Mahout is basically an artificial intelligence engine kind of thing. You might have gone to all these websites like Amazon and Flipkart, and you might have at some point of time done some kind of search on top of it. Let's say you're going to buy a mobile. What you're going to do is you'll do that search on the mobile and then on the website, and then you're going to close that website. Again, let's say after some point of time you're opening that same browser or maybe some other browser, and you are doing something completely altogether different. But again, somewhere on the sidelines, you will see those same suggestions for that same thing that you were searching on those websites coming into there. And that is where Mahout is into picture. What Mahout is trying to do is, it is trying to influence you as an end consumer to buy that product, which you have not done in your previous cycle. So these are three different components. They are all basically built and a layer of abstraction on top of the underlying MapReduce and HDFS. Then you've got Apache Uzi, which is more like a workflow. If you're coming from a Unix background, you might have definitely written or used some kind of cron job or cron tab in your experience. What does it do? It actually helps you to start jobs, it helps you to stop jobs, it helps you to run job at a specified interval of time. That is what Apache Uzi is, but more in terms of the Hadoop world. It helps you to schedule your MapReduce job, it helps you to schedule your Hive, your Pig job and your Mahout job at a specified interval of time. It helps you to do that, as simple as that. Then we've got frameworks like Scoop, we've got frameworks like Flume. A Scoop is a simple thing, right? When you're doing a big data implementation using Hadoop, most of the time you would want your transactional data in an OLTP system. You would want to pull that data from the OLTP system. back into your distributed file system, Hadoop distributed file system. You will use Scoop to do that. Scoop provides a very, very simple interface for you to pull that data from the RDBMS and put that into your Hadoop implementation. Flume is more about the unstructured data. So if you've got a, let's say, an application like LinkedIn or a Twitter, which is like continuously generating unstructured data, which would have videos, which will have audios, it will have images. Flume is the framework which is going to help you pull that data from that system and put that into HDFS. And by the way, these two frameworks not only help you pull the data from the system, but they also help you push the data on these systems. So the traffic is both ways. The framework provides you the facility to pull and push the data from these systems. All right. So having understood the ecosystem and the Hadoop as a fundamental, let's see a little bit more in detail about what Hadoop is all about. What are the various different components of Hadoop itself? Hadoop as a framework itself. Hadoop as a framework, to put it simply, comprises of two portions. One is the HDFS. What is the full form of HDFS? Hadoop Distributed File System. And the other part is MapReduce. Now, as we have understood, HDFS is all about storage. You've got a big data file, maybe of size 1 zettabyte. HDFS helps you to store it. And in the course of these sessions, we'll see how Hadoop framework helps you to save these files across the cluster of the machines. MapReduce programming, in contrast to that, provides you the analytics algorithm. So once you've saved your file on HDFS, MapReduce helps you to do analytics on top of it, right? And by the way, that helps you to do analytics on the entire population of the data, as I said, right? Let us see a couple of more details about HDFS and how it pairs up with MapReduce in a typical arrangement. So as I said, there are two parts to it. One is HDFS, the other part is the MapReduce algorithm. The HDFS part, in a typical cluster, in a typical collection of machine, there will be one heavy duty server called as admin node, and there will be a gamut of commodity machine. Let me tell you what commodity machine is. A commodity machine is something like is a machine something like people like me and you use. An 8 GB RAM kind of laptop or a desktop with 1 terabyte of disk, and let's say an Intel i7 or a AMD Athlon kind of processing power. So those are commodity machines. A typical Hadoop implementation would have one heavy duty machine called as admin node and a couple of let's say some 10-15 commodity machines spread across the cluster. Now let's start with understanding what this admin node is all about. This admin node typically runs two daemons on it. One is the job tracker and the other one is the name node. Now let's do a direct correlation. Name nodes directly correlates to the HDFS part of it. Name node on the admin node manages everything with respect to storing, managing and accessing these huge files, big data files that we are talking about. In contrast to that, the job tracker is more about managing MapReduce algorithm implementation. They both run at the admin node level and they both are daemons, right? A typical admin node machine is a heavy duty machine, probably a Xeon server kind of processor or a 64 GB RAM kind of machine. We'll see the details of that in the subsequent unit. Now let's move on to the commodity machines. What are commodity machines? Commodity machines are the machines which save the data that you are trying to save on your distributed system. So it would always have some two daemons running on it. One daemon would be data node and the other daemon would be task tracker. The data node is going to take care of the distributed file system aspect of your implementation, and the task tracker is going to take care of the executing the MapReduce algorithm implementation part of the aspect. The data node is going to keep on interacting with the name node. The task tracker is going to keep on interacting with the job tracker. All right, so let's see how Hadoop solves the limitation of the existing solutions like RDBMS based data warehousing solution. First of all, as you might have guessed it, it helps you save the whole file. So you've got a zettabyte size of file, HDFS helps you save it. That's one part of it. The second part of it is, no matter how big your file is, you have got a framework which will help you to do the analytics on top of the entire set of file. Now, just like data warehousing, you don't have to cut out portions out of it and then do the analytics. MapReduce as an algorithm helps you to do the analytics on top of the entire set of data. And by the way, let me tell you, while in data warehousing it was taking days or weeks or months to do this analytics, here in Hadoop it would just take maybe a couple of hours to do this analytics. And having said that, since this is a scale out architecture, you can even toggle with the amount of time it takes to do the processing. Right? So let's say if in your cluster you've got a one name node and 25 commodity machines, and your 1 zettabyte of file is taking 2 hours to do the analytics on top of it. If you make the commodity machines, increase the size of number of commodity machines from 25 to 50, the time it takes to do the computation would become exactly half. And that's how you play with the numbers, right? You keep on scaling out, you keep on increasing the number of commodity machines, your entire computation or the processing time inversely directly keeps on coming down. So that's how Hadoop solves this problem. So let's see what we have understood in this unit. We've understood what big data is and how big data is like huge and complex, and it becomes a challenge for you to access it, read it, cache it, and store it. We've also seen what are the existing solutions like data warehousing built on top of RDBMS. We've seen what are the challenges with respect to that. We've moved to Hadoop as an open source framework. We've understood what Hadoop is. And we've understood what Hadoop is like, how Hadoop is meant to be doing full analytics using the entire population of the data. And then Hadoop also has another aspect. We've seen how Hadoop has a MapReduce algorithm built inherently in the framework itself. And then we've also seen how Hadoop provides a solution in terms of not only storing the data, no matter how huge that file is, but also providing you a framework to do analytics on top.